Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. Today on the show, the centerpiece of our discussion, which we'll eventually get into, is called SCRUF-D. That's an acronym for Social Choice for Recommendations Under Fairness, and then we throw on the D for Dynamic, SCRUF-D. This is a novel agentic approach. As we get into the everything agentic world, the core concept is take every fairness concern you might have and represent it as an agent. Each agent then, in each iteration, acts in the best interest of whatever they're trying to accomplish. That's the allocation step. Then there's a preference aggregation step, in which is something like voting happens, where these agents all come together and decide on what recommendation to give. We'll get into all that and more during the interview.
I'm Robin Burke. I'm a professor in the Department of Information Science at the University of Colorado Boulder. I teach a wide variety of classes in information science. I teach machine learning. I teach network science. I teach other sort of data science topics, recommender systems courses, and other sorts of kind of data analysis sorts of things.
When did recommender systems first get on your radar?
I got my PhD in 1993, so I've been around in this academic scene for a while. And if you looked at that dissertation today, which was really about recommendation in the context of intelligent tutoring systems, we would call it a recommender system, but that term did not exist in 1993. So in some ways, you could say the path of my dissertation research was sort of a recommender systems dissertation. But again, that term didn't exist. So then you would have to kind of go back to maybe like 1989, 1988 to say, okay, when did you actually start working on recommender systems? So that's one kind of way to answer that question. Another, I think, important connection is the connection to case-based reasoning. So case-based reasoning is a kind of AI technology that was contrasted to, say, rule-based reasoning or expert systems that were very prevalent at the time, to say the way that people solve problems is by reference to things that they have solved before. And so the question is not, how do I reason about this from scratch? The question is, how do I find something in my memory that's appropriate and adapt it so that it meets the needs of the current problem? If you just sort of grab onto the retrieval piece of case-based reasoning, it kind of looks a lot like what you would expect of a recommender system. And so there is a kind of close connection there, which I think doesn't get recognized that often, but that's the route that I came into recommender systems. So once I finished my PhD, I went on and started a postdoc at the University of Chicago. And the professor I was working with there, Professor Christian Hammond, who's now at Northwestern University, he was trying to apply some of these same case-based reasoning ideas to things that looked that were kind of consumer-type domains. And he was very much interested in this, like, okay, how do we, when the solution to somebody's problem is a product, like a new car, how do you find the appropriate item? That was the sort of beginning of what was at that time we called knowledge-based recommender systems, and that's how I started working in that field. And again, term didn't exist for a couple of years after that. And once people started talking about recommender systems, the other folks who were working in the area, that term came into being. We realized, oh, that's what we're doing, and so that became the kind of umbrella term for all of these kinds of technologies.
As I look through your long list of publications, one that jumps out, just because it's incredibly well cited, is Hybrid Recommender Systems, Survey and Experimentation. So just a little while later, that word's there in the title. We have recommender systems. As a point in time, if you can recall that paper, what was the state of the art? How did people approach recommender systems?
Nowadays, if people are building AI systems, you basically put everything in it. You throw in all the features you have, the user data, the item data, metadata, anything you can get your hands on that might help you sort of unpack what the user item interaction was, you try and make use of it. But this was not true at the time that I wrote that paper. And at that time, there was kind of these two camps. Well, it was like 2.5 camps. So one camp was the people who are doing content-based recommendation, and they were saying, look, you want to understand the features of the items. You want to, learn what it is that the user attends to when they're thinking about, say, a movie, the genre of the movie, the actors, or, other kinds of consumer items. What is it the user is paying attention to in terms of the features of the item itself? And then the other camp, there were the collaborative recommendation people who are saying, no, feature catalogs are unreliable, hard to construct. All you really need is other users, their patterns of interest. You can uncover the important features. That's the whole logic behind collaborative recommendation, is that maybe these content features are not as necessary because, all of that is recoverable from the signal that you get from other people's preferences if you have a big enough user base. And then I say 2.5 camps because the other camp was the one that I was started out in, which was the knowledge-based camp that basically said, in addition to the knowledge features and in addition to this sort of user preferences and things like that, it's useful to have domain knowledge and to know that, the relationships between different kinds of features. If you are going to, have a faster CPU, it's probably going to cost you more and you're going to need a bigger power supply, things like that, like relationships between things. Those three kinds of recommendation kind of coexisted at that time. It was kind of a back and forth as people saying, this one is better for that reason and this one's better for that reason. And so what I was doing in that paper was actually saying, what are the different ways that we can combine these types of recommendation? And that was not that common back then. And there were some papers, but I kind of laid out, okay, here's all the ones that I could think of, and talking to people about it, it's like, okay, here are the ones that people have tried. Here are things that don't seem like they have been tried, but the different ways that we can imagine combining these different types of recommendation. What kind of systems might you get? And does that tell us about things, for one, it lets us categorize things that already exist, but then it also raises questions about, okay, what other kinds of hybrids might we build? Out of this taxonomy, what are the gaps in there? And then so that was the survey part. And then the experiments part was, I ran some experiments where I added knowledge-based recommendation, which was again kind of this sort of poor cousin of these other much more common techniques, to say, well, what happens if we use that as one of these hybrid components? And so I did some experiments around that. And I think one of the things that did was, and the reason that I think it's been cited a lot, is that people realized, it's not necessarily an either or. We can put these two kinds of recommendation logics together, and that there's benefit in doing that, and there's multiple ways to do it. And interestingly, one thing that happened, there's a taxonomy in there, again, of all these different sorts of combinations one might have. And some of them I just didn't think were feasible. And so I marked them as things like, we probably no point in trying that because it's probably not possible. And then people went ahead and built systems like that. So that taught me my ability to predict, was not that, what made for a feasible project. It's, not that good. So probably I should have just left the taxonomy there and let people explore it, which is what they did anyway. So anyway, that's that paper. And I think a lot of people built systems, building out different parts of that taxonomy. And now, like I was saying, people would think you were crazy if you had some content data and you decided not to use it. It's like, no, of course you use all the features that you can.
And has that taxonomy, if you went and took up the same project again, have new labels emerged, or has the popularity of some of its components shifted?
Oh, wow. That's, I have resisted revisiting it. A version of that paper appears in the first Recommender Systems Handbook, which is kind of the starting point for people that want to do research in recommender systems, kind of understanding what's been done. It's on its third edition now. But when the second edition came around, they were like, if you're going to use this chapter again, we're going to have to totally rewrite it because the landscape has changed. And, I didn't take on that task, and I really haven't revisited it since then. One of the ideas is sort of feature extension, where you basically take the set of features that a particular algorithm sort of consumes, and you add the features of the other type. So you take an algorithm that takes content features, and then you just add collaborative features to it and just run the same recommendation logic. And that is just kind of what every system is now, right? So that's sort of one technique of sort of putting all the features together. Sometimes you will see models where we sort of model the item separately and we model the user separately, and then combine the models at the end. That's also something that I talked about in that paper with different models, different types of models back then. So I think a lot of it does map to what people are still doing, but mostly I see, these sort of more feature extension kinds of models where we have models that can take more kinds of features and larger sets of features now and look for, more complex nonlinear associations. And so anyway, that has changed what it means to be a hybrid recommender. Now it's just a recommender.
Well, for people working on recommenders, they want to have some success measure. And although there's a couple schools of thoughts like accuracy and F1 and recall and these kinds of tools, the sort of obvious tools are there for you if you're just concerned with how do I build the most successful one? Like if the library is recommending books, method A gets more checkouts than method B, you prefer method A. But as the field has grown in sophistication, what other concerns do people who build and work on recommender systems develop?
I think we've expanded a lot, kind of our scope of what we think of as properties that a recommender system should have. One of the things that I think has happened is that recommender systems have moved into a lot of different domains, a lot of different areas of life. You mentioned like libraries recommending books. So one of the things we know is that popularity is a very strong signal because people get interested in the same thing all at the same time. That's just sort of the nature of how things work. And so, in fact, if a library recommended the popular book to everybody, they wouldn't have enough copies. So it's actually in the library's interest to kind of spread out the recommendations of the most popular books because people are going to ask for them anyway, and because, again, they're going to frustrate people by saying, oh, you'd really love this book, and then you click on it and it says, oh, no, we don't have any copies of that. Get on this list and you'll get one in 2 months. So I think this question of like, what is the user experience is not always well captured by this idea of what would the user click on or, these what we think of as accuracy. And I think the personalized nature of recommendation means that even defining accuracy is a little bit tricky. In the library's case, you might say, well, one of my criteria for a good set of recommendations is that it's actionable, that the things on there are things that people can actually check out. And I think that's true in e-commerce too. You might say, well, I don't want to recommend things that are back ordered. I'd rather recommend something that the user can buy right now. So that's one kind of thing. There's a kind of a user experience aspect to it, thinking about all the different aspects of user experience. I do work now in news recommendation. And in news, we have this idea that there are things that you want to know about. Maybe you want to know about the score in the Rockies game. You probably don't want to know about the score in the Colorado Rockies game, actually, but especially if you're a Rockies fan. But then there are things you should know, right? So a war breaks out in Ukraine, there are, big national events or whatever they are. They might not be the kinds of things that you typically click on, but it's part of, the journalistic enterprise to keep you informed about important events. In the news recommendation work that we do, we think about this balance a lot. It's like, okay, what does the dictates of journalism in terms of having an informed citizenry, what do those say about what should be recommended for news? And then what does this personalized aspect say that, okay, you're going to be more interested in news in your town as opposed to things that are far away or things that are relevant to your particular interests, whatever they are. So that's another way of thinking about expanding how you might evaluate the recommender system output is to say, well, how does it meet other needs that that are not necessarily sort of tied to this a user's direct interests or the things that they've clicked on in the past? In the last 10 years or so, people have started to get also very interested in the impact of recommender systems on what we call providers. So some people call them creators, but the person who is providing the item to get recommended in the system, not always the person who creates it. So just as a general term, we have this term provider. So the question then is, well, what is the impact of the recommender system on the providers? Let's take music for an example. Do people who are artists and songwriters and performers, does the system treat them fairly? Do their items get recommended? You can imagine that it would be a big problem for the music ecosystem if only the very top stars had their stuff recommended. It would be very difficult for new musicians to break in, difficult for new music to get heard. There has to be those ways for, the system to kind of keep going and to evolve. And yes, There are songs from 50 years ago that people like to listen to over and over again, but that doesn't mean there aren't songs that were released last week that deserve a hearing. And so if you measure your system based on whether people click on things and listen to songs or not, you might miss the fact that you are, say, leaving certain artists out in the cold, or certain genres are emerging and you're not giving a voice to them. So again, you were talking about the complexity of recommending, of deciding what a recommender system should do and how to evaluate its output. This is, again, another aspect of thinking about the recommender system, not like a single list of things, but over the course of time, over a set of recommendations that it delivers. How well does it cover the space of things that people are interested in, the space of things that providers are creating?
Well, your example with music artists and popular ones versus emerging ones is very intuitively clear for me when you say you'd like a fair system. I certainly don't want to sign up for an unfair system. But if we get a little bit more rigorous, maybe a bit mathematical, what does it mean to be fair?
I wish I knew. This is something that we wrestle with a lot. And I think that it's not surprising because fairness is not a computational concept. It's, if Western philosophy, it goes back to Aristotle, goes back to, theories of justice. And people have a well-developed sense of fairness. You can ask any 5-year-old about whether they think what their brother got was fair or not. Like this is something that's part of human nature. And Van der Waal, found out that monkeys have a sense of fairness. Like this is something that's very core to us. But it's also, like a lot of sort of human attributes, it's something that's really hard to define. So the best thing we can do is sort of look at very specific cases and say, okay, what does fairness require in this case, rather than trying to sort of answer that question in general. People, reasonable people might differ, but you might say, for example, go back to music, if women artists are listened to by a certain percentage, and you kind of know what that is because you can see what people stream, then our recommendations should probably have that many women artists in it. Like that proportion should line up, right? And if it's fewer, then maybe our system has a problem, right? Maybe our system should be recommending things a little bit differently. So, and that's, Christine Bauer in her research has found that this is true. I'm not sure exactly which music service that she was auditing, but she found that women artists were recommended less than their popularity would otherwise indicate. And that's a problem with the recommendation algorithm. It's hard to know exactly what signals it's picking up on, why that's happening. That's a whole interesting set of things to explore. But just knowing to pay attention and to identify those areas of unfairness, that's something that I think is extremely important. And so that's an example of a technical definition. You might say, okay, let's look at the consumption pattern and see if the recommendations match that. It's a little bit tricky because the consumption pattern itself is influenced by the recommender system. And so, you run the risk of there being some feedback there. So then the question is, can you kind of figure out what a fair outcome would be some other way? And maybe that involves not looking at the system data, but doing surveys or doing other kinds of data gathering that would help you understand, what should qualify as a fair output for the system. But I'm not going to pretend that this is easy. So I've been working for 7 or 8 years now with the micro-lending organization Kiva.org, and they do crowdsourced micro-lending in the developing world. We've been on this journey with them trying to understand what do they mean by fairness when they think about global financial inclusion, which is, their mission. And we're still uncovering things. So it's an ongoing task. And I think of it kind of like any other requirements analysis. It's like, you discover more as you build systems, you discover more things about what they need to do. And fairness requirements are like that. So you shouldn't think of like, oh, I come up with my one definition and we're done. It's much more like you're going to discover new needs around fairness in any system that's got a sort of complex set of stakeholders like that.
Yeah, I agree. It's definitely not an easy problem to solve. And if you're going to make a change in some system, then it's a dynamic system. Things could evolve. Even a well-intentioned change could have unexpected consequences. With maybe a little bit of a fear like that in mind, how do you approach the problem?
Good question. I think humbly, I think you want to do these sorts of experiments in advance. One of the things that I would like to see more research on, I've done a little bit of this work myself. I think there's a lot more to do, is modeling of recommendation ecosystems. So, we have the recommender system itself, but it's embedded in this system where, the providers react to how the recommender system is treating their content. Users react to what the recommender system is giving them. And some of these effects may only emerge through that interaction, through the evolution of that ecosystem over time. You kind of want to know, if I'm making this change, how is that going to have these ecosystem effects? If I'm going to institute some policy, how is that going to have these ecosystem effects? And if we had better tools and kind of a better understanding of how best to model recommendation ecosystems, then I think we could maybe do it empirically in the simulation before we try things, and roll them out. I think a typical industry practice is to say, well, I'm going to do some rollout, but it's to a very small fraction of my, of folks, and I'm going to kind of see what happens and decide whether I like the consequences or not. But I think simulation could also help a great deal. And it's also the case that if you're someone like me, I don't own a large web company, so I can't do those experiments at that scale. A good set of simulation tools for recommender ecosystems, I think, could go a long way. And not to say some of that work hasn't been done. I think we have some interesting results on how unfairness can build over time, the kinds of biases, selection and presentation biases kind of build on itself. And so, pretty soon you're only recommending Taylor Swift and Beyonce and nothing else, So, some of that work has been done, but I think there's a lot more opportunity for it.
Could you, I think we're going to introduce this concept SCRUFD for the first time.
Sure.
Would you mind giving the acronym and telling me a little bit about the framework?
Yeah, so it stands for Social Choice for Recommendation Under Fairness. Dynamic version of it. We had an earlier one that didn't have exactly the same properties. I do confess that it's one of those cases where we kind of came up with the acronym first and then tried to make it fit the what we were doing. The basic idea behind that and the motivation for developing it come from some of our frustrations with the way fairness in recommendation had been kind of researched and studied up to that point. And if you look at a lot of the research, you'll find that people identify a single dimension along which fair recommendation is being studied. So maybe like before we were talking about female artists in the music streaming kind of setting. So we identify that. Then we come up with a measure like the one I talked about before, like, calibrated exposure, based on listening history. That's where our algorithmic work starts. It's like, okay, we have this dimension. We have a mathematical definition of it. Now let's build our algorithm, whatever we're doing with the system. And we say, look, we've improved fairness towards women artists, and then we publish our paper and we're done. But what we found when we were talking to the folks at Kiva and other places that we looked in the world is that there isn't one dimension. There isn't just one kind of fairness that you care about. You might care about women artists. You might also care about artists that sing in languages other than English. You might care about different musical genres that get different kinds of exposure. The list goes on. And any given company is going to have to decide what their priority is in terms of, how to think about those different protected groups and audiences and so forth. But the fact is that one thing is not going to cut it. Like one dimension that's just not realistic in terms of what fairness properties people are going to care about. And these previous techniques, it was very unclear how you went from 1 to 2, how like you could add another one. And some people had done that. And usually what they would do is they would assume that everybody's fairness metric was the same. So if it was, sort of calibrated exposure, then it was calibrated exposure for everybody. And then maybe we could expand to, a second dimension of fairness. And both of those seemed like problematic assumptions to us. So we started out with this idea. It's like, okay, what if we can have a multiplicity of fairness concerns, lots of dimensions on which we care about fairness, maybe not too many, but a handful, definitely not one. And what if we want to make it be the case that we don't have just a single definition of fairness? that we might, for different kinds of use cases, for different concerns, we might need to define fairness in multiple different ways. So that was the starting point. It's like, okay. And then the question was, well, what is the solution going to look like such that I can try and, advance multiple fairness concerns at the same time, even if they're defined in these heterogeneous ways? And at this moment, when I was wrestling with this problem, I had the great fortune to encounter my colleague, Nicholas Mattei, who's he's a computer science professor at Tulane University in New Orleans. And he is a social choice expert. And, thinking about this problem together, we came up with this idea that basically you can kind of represent these different fairness concerns in the system as agents, as separate entities that kind of have goals they're trying to accomplish, different fairness objectives relative to the outputs of the system, and they're kind of all pursuing them at the same time. Like this was a kind of framework that would let us have lots of fairness things going on all at once. And for the social choice people, it's like, of course, there are different individuals. They all have their own objectives. They're pursuing them all at the same time. That's like what social choice is all about. And so the question was, how could we kind of marry recommendation and social choice in a way that lets us pursue these multiple fairness objectives at once? The other nice thing about the sort of social choice framework is it doesn't make any assumptions about what different agents' preferences are. So it doesn't matter that this agent cares about the language of the singer and this agent cares about whether the singer is female or not. It's like those are just different agents, each doing their own thing, trying to pursue their own objectives. So the way Scruff works is that it's formally what we would call a re-ranker, in the sense that the recommender system is sort of independent of the recommender system, whatever it is. So you have your recommender system, it personalizes things to the user, and then we apply the fairness objectives to that result. And so that makes sure that we don't get too far from the things that the user is actually going to be interested in, but it allows us to kind of build on whatever it is the recommender has already produced. So maybe the recommender gives me 100 things, and then the re-ranking system gives you the 10 things that we're going to supply as the recommendation list. And so it happens in 2 stages. And these are ideas, again, that come from the area of social choice. So the first step is allocation. So every user that comes along and needs a set of recommendations, we think of that as a recommendation opportunity. Like this is a chance to pursue the fairness goals of the system, in addition to providing, personalized recommendations. But this is a chance that the agents have to pursue their goal relative to fairness. So the allocation step says what agents are relevant to this opportunity. Now, different users may constitute different kinds of opportunities to pursue different kinds of fairness, right? So if I'm somebody that only listens to country western music, then probably the genre diversity thing isn't going to get much traction with me. Like you could recommend that rap song, but I'm maybe not going to listen to it. Although of course there is some, crossover stuff between those genres too. But if you believe that someone is not amenable to a particular dimension, then maybe you allocate a different agent and not that one. So there's this idea of compatibility. There's also this question of where is the system's need right now? So where has the system been able to successfully meet its fairness objectives and where hasn't it? And this is one thing that I think sets our work apart from a lot of other folks. When they evaluate fairness, they kind of get the system to produce all the recommendations for everybody, and then they see how fair was it. But in practical contexts, like the Kiva one that I was talking about before, the fairness needs arise because the system has delivered certain recommendations in the past, like in the last week or something, and now certain providers, for example, have been left out. It's like, okay, we have a problem now that we need to deal with. We haven't been recommending any loans from these countries lately. We got to, change things about that. So the fairness needs of the system are dynamic, and that's the D part of Scruff D. And so the system has to be able to respond to that by allocating the agents that are kind of in need of being allocated. So that's this allocation part. What fairness concerns are going to be active in this recommendation opportunity when a user comes along? And then the next step is, okay, we have our agents. We have the recommender, which in some sense sort of stands in for the user, being the user's personalized preferences. Now we have to combine the preferences of the user, as represented by the recommender, with the preferences of the agents. And the agents are trying to promote certain items that would, improve fairness relative to their concerns, whatever they are. And that's also a social choice problem. So basically, you can think of it like a voting rule, like we're all voting on what items are going to get recommended, basically. And so the user gets a vote, but the agents also get a vote, and then the recommendation list comes out the other end. So each of these problems, sort of social choice, preference allegation, and allocation, those are well-studied problems in the social choice literature. And so what we've been doing is kind of trying to understand, okay, what are some good options in terms of these existing mechanisms for allocation and social choice? How do those work in the recommendation context? How do those work with different combinations of different kinds of fairness objectives in real data sets with reasonable fairness concerns? I think this question of how do we find out what people who are implementing these systems really want to do? We haven't completely closed the circle on that, and I'm happy to talk more about it. But that's kind of the research that relates to Scruff, is sort of trying to understand what are the capabilities and limitations of this more flexible, more heterogeneous way of thinking about fairness in the recommendation context.
Yeah, I like the multi-agent approach a lot. When it comes to that aggregation, I guess there's lots of ways it could be done. Could you talk a little bit to how you chose to do it? How do you get from the set of agents that will in some cases agree or disagree to the reordering you might do of the recommender's output?
So there's kind of two questions. So one is in the allocation piece. So one obvious thing you might say is let's have a lottery. We pick one agent randomly based on what the compatibility issues, the fairness needs of the system. We just construct a probability distribution, conduct a lottery, pull one agent out and say, okay, you're active to now. This is your opportunity. You get to influence the recommendations now. Or you could say, let's allocate everybody, but with different weights depending on how important we think they are. And so, so that's kind of this question of what is the interface coming out of allocation into the preference aggregation part? And then the preference aggregation part, there are just some different kinds of voting rules that folks in social choice have studied. So the simplest ones are things that are, just based on scores. So you say, okay, you get 5 if you're the top ranked item, you get 3 if you're the second ranked item, all the way down. And then you just add up what items get the highest scores and do that. There's even simpler mechanisms where you just say, okay, if the agent likes it, we give it a score boost, and then we re-rank when we're done. We're just looking at a variety of these different techniques. Another way is greedy sublist re-ranking, where you basically have some metric about the quality of a list. And so then you start with a list of one item and you say, okay, what would be the second item that makes this the best list according to this criterion? And then you have a list of 2 and you ask, okay, what would be the third item that makes it the best list, and so forth. That's a pretty common technique in recommendation for re-ranking systems. So what we have found is that depending on the data set, depending on the context, it sometimes doesn't matter what the voting rules are. The allocation piece does most of the work. So deciding which agent is active. But that's not always true. So sometimes you get situations where it does matter which voting rule you use. And so the ones that just do kind of numeric score bumping, those sometimes achieve a better trade-off between fairness and accuracy than ones that are kind of not taking the magnitude of the score into account. So if you think about the Borda rule, which is the one that just assigns a score to each position, if the thing in the number 1 position, has a, predicted value to the user of, 0.99, and then in the number 2 position has, 0.33, then, there's a big gap between 1 and 2. And if you just look at the ordering, you're not capturing, those score differences. And so again, depends a little bit on the recommender and on the data set. Sometimes being more sensitive to those score differences matters.
Well, there's another approach, I'm sure you've encountered it as well, in fairness, is to use machine learning regularization, that we're not just going to optimize for accuracy, but augment the loss function. We want to do well on accuracy plus some fairness constraint, or maybe plus 2 or 3. sort of like a do it all in one step approach. Could you contrast that approach to yours, where you first get the standard recommendation algorithms output and then your methods kick in after that?
Right. And actually, I've done some of that work myself, nothing against regularization. I think the reason why we're going the way that we are going here is a couple things. One is it does get much more difficult to do the regularization piece when you have multiple dimensions, when you have, you're trying to balance against multiple objectives. And it's very finicky to like tune those objectives relative to each other as well as relative to the main personalization objective. I have seen people do it with two. I can't think of somebody who's tried to do it with more than that with any degree of success. And when you look at those systems, often they do make this assumption that the fairness definition is the same everywhere. It's the same for every dimension. So there's kind of this ball, and the distances are relative to the same metric in every dimension. So I think it is tricky to get that right. To be fair, it's also tricky to get Scruff to work right. There are, parameters that you have to adjust. But I think one of the things that's nice about it is that those parameters are things that don't require retraining of anything. So if we think about how Scruff is working, I can change the definition of an agent. I don't have to retrain my recommendation model. I can say, I want to crank up the weight on this kind of fairness because I don't like the results that I'm seeing. I don't have to go back and, tune my regularizer again. So I think there's that benefit. I think it's a more flexible and dynamic system. One of the dangers, this is something that we have thought about, and done some investigation ourselves. One of the dangers is that if your recommender, has a lot of, say, popularity bias, like it tends to recommend popular items, some algorithms are worse than others in that respect. If you're not getting diverse outputs, if those female artists don't appear anywhere in the recommendation set, then you have nothing to re-rank, right? You can't promote something if you don't have it. So that's a danger. And I think we've looked at that by trying to explore, it's like, okay, how much does the re-ranker change the recommendation list? How far down into the recommendation list does it have to go to find items to promote? And that does vary by algorithm. So some algorithms being more biased than others. So part of it is choosing a good algorithm in the first place. I'm not going to name any names, but some algorithms just are, have more popularity bias than others, and you can train in different ways to try and avoid popularity bias and other kinds of biases. And then the other question is, are you getting enough items to be able to build a re-ranked list that it has the properties that you want? And so far, we have found that for the algorithms that we're using in our studies, it's not the case for the most part that it's unable to find those items to re-rank. We usually work with lists of 50, not for any good reason, just because computational limitations. We usually find that you don't have to go anywhere near 50 to find to find those items and promote them. But that is also somewhat data set dependent. And so in some cases, we have found that the re-ranker has to go deeper into the list than we would like. And so, one solution is you rank some more items, you have a longer list, or you consider tweaking the algorithm to try and get a better result. I think it's actually something I've never seen really much work on, is this question of whether we do a little bit in both areas, whether we do something to the algorithm to try and make it provide a diverse set, and then that gives us a better basis for re-ranking. That kind of combined optimization, have not seen a lot of work on that. I did have a student working on that problem, but then he graduated and then he went away. It's like, no. So yeah, I think there is work to be done there.
And what's next for you?
We are continuing to kind of explore this sort of architecture and the possibilities associated with it. I think one thing that we're particularly interested in is thinking about more realistic kinds of displays. So recommender systems as a field very much historically has concentrated on this idea that a ranked list is the output, right? So the top 10 things, right? This is like 90% of Rexis papers, this is the assumption about what the output of the system is, maybe more than 90%. But real world displays are more complex than that, right? So you get multiple carousels, you get, different kinds of displays, you get, there's recommendations happening in multiple places in multiple ways. You have more complex displays that aren't just, 10 items in a list. And recommender systems research doesn't have a lot to say about that right now. People in companies have to solve these problems, of course. But I think this question about how do we think about recommender systems when we want to think about the display as a more complex object and not just a ranked list. And we think that some of the ideas behind Scruff can actually be pretty helpful in that regard, especially this idea of allocation. So instead of saying, I'm going to give something a score and that will cause it to be ranked 1 through 10, we could say every piece of real estate on the screen is something to be allocated. And so, some of those allocations, the headline above the fold, the most, that's the thing with the most utility, but then there are other things, to the side, there's, whatever the display is, those other things have the utility of their own. And then the question becomes optimizing the allocation. Like the social choice stuff has infected my brain, I guess. It's like, okay, how do we optimize the allocation of items to display positions where the ranked list is a special case and we can handle a wider variety of displays? So I'm super interested in that. And I think there's some, I think we've got some ideas about how to make headway on that. The other thing that we haven't talked about at all, that would be a whole nother conversation maybe, is this question about thinking about providers in particular, the people who are standing behind or creating the items that show up in recommender systems, thinking about them as users of the recommender system, right? We think about the people get the recommendations, but these other folks are also users and they have needs. They have user interface needs. They have explanatory needs. Like there's a whole set of things that I think we should be doing and considering as part of our the sort of scope of recommender systems research. Hasn't gotten a lot of attention so far, and it crops up. You do see sometimes people interview like YouTube creators and things like that, and try and understand how they interact with the recommender system. But this is part of my whole ecosystem argument I was making earlier, and I just think we need to take that set of users kind of much more seriously as sort of first-class users of the recommender system.
Is there anywhere listeners can follow you online?
I do a terrible job of posting things. Probably the best way is to look at publications on Google Scholar. I am on Mastodon and on Blue Sky, but I can't say I do a heck of a lot of posting there. I do when we have publications and things like that. You'll find things there.
Very cool. We'll have links in the show notes for listeners who want to follow up. Robin, thank you so much for taking the time to come on and share your work.
Happy to be here. Thanks for the opportunity.